Problem says find and draw the total displacement vector for a ladybug that starts at the coordinates 8, 2 and ends at the coordinates 3, 6. We want to be able to first plot that initial starting position for the ladybug, and let's also plot the final position too. So I'll go over 8 units, then we'll go up 2 units. This is going to be the starting point for the ladybug. Now let's go to the coordinates 3, 6. So we'll go over 3, up 6. Okay, great. Now, when we draw the displacement vector, we want to start at the initial position and then go to the final position, drawing an arrow. We'll call it delta, and then we have to give it a letter, but we're not going to use x because it's not just a horizontal displacement. And we're not going to use y because it's not just a vertical displacement either. What we'll use instead is we'll use the letter r, delta r. But let's make it clear that it is a two-dimensional vector by putting a little arrow over its head. And we also want to be able to find the displacement vector in either component form or vector form. Now this one's not going to be too tough to find. I can actually count to the left here. We go over 1, 2, 3, 4, 5 units left. And we also go up 1, 2, 3, 4 units. So the final answer for this is going to be -5, 4. That is a component form way of expressing the vector delta r, which is the displacement of the ladybug. But we want to go farther with this and come up with an analytical way of finding the delta r through mathematics. So we want to go back to the one-dimensional idea that we had used in the past, initial plus change equals final. And if you recall, in the past we had used xi plus delta x equals xf. Or if we were dealing with a vertical dimension, we would use yi plus delta y equals yf. Now we can actually do that here. We can separate our displacement into two components. So if we want, we can use xi plus delta x equals xf, and we'll also use yi plus delta y equals yf. Now let's take a look at our coordinates and figure out which is which, right? So this is the initial point. So this is going to be xi, and this will be yi. We go to 3, 6, so this is xf and yf. This will be delta x and delta y. Now let's pretend that we didn't just count that right now and we wanted to solve it through mathematics. We would rearrange these formulas, getting delta x equals xf minus xi, and delta y equals yf minus yi. And now we would just substitute in. So delta x equals 3.0 minus 8.0. which is, of course, -5. And delta y equals 6.0 minus 2.0. Therefore, delta y is 4.0. Okay, in this way, we've treated both of the dimensions independently, and that's totally fine. But what I want to do now is I want to introduce a new way of approaching the problem, and that is going to be through the formula Ri plus delta R equals Rf. Now, x and y are one-dimensional considerations. This is a two-dimensional vector. Okay, now what does that mean? That means that if we want to plug things into these, we have to put both the x and y components in together. Ri is what's called a position vector, which points from the origin to the initial point. This is Ri. Rf will be a position vector which points from the origin to the final location for the ladybug. Notice that the same ideas that we had used for one-dimensional motion are still present here in two-dimensional motion. And what I mean is that Ri is a position vector. It is the initial position, and the initial position starts from 0. This would be the final position. And the final position starts from 0. And this, of course, is the displacement, but it's the two-dimensional form of it. What is Ri in component form? Ri is a vector which has an x component of 8, and it has a y component of 2. Rf is a vector which has an x component of 3 and a y component of 6. So this is just another way to express that vector mathematically. Now what we can do is we can plug into the equation. So put in your 8, 2 over here. I'll leave off the decimal significant figure there, just for simplicity's sake. And then plug in your final vector as well. Now, just like we would do with any algebra here, when we want to solve for the unknown variable, we subtract this from the left side, and we'll also subtract it from the right side. Now, I'm going to do more videos on this shortly, on how to subtract one vector from another. There are rules for it, but I'll give you the basics here. It shouldn't be too tricky to see what happens. The x's get subtracted, so you do 3 minus 8, you get -5, and then we also subtract 6 minus 2 to get 4, and there we go. We did some two-dimensional algebra here. And we arrive at the same answer that we had found just by counting unit squares here.